Hey guys, welcome to question FM333 of the Further Maths Fortify study guide. Before this question begins, we're given the following information. We're told that Geordie is trying to find that special someone at a party. The positions of two other people, A and B, relative to Geordie are presented below, and then we're given a diagram that looks like this one. We're given the information described in the diagram as dot points. We're told that the direction of A from Geordie is north 73 degrees east. The direction of B from A is south 47 degrees west. The direction of Geordie from B is north 31 degrees west. And the distance from A to B is 7.1 meters. The question then goes on to say, Geordie strikes out with person A, then goes to person B and strikes out with them, then returns to his original position, sad and dejected. The distance in meters that Geordie travelled is closest to what? So in order to answer this question, we need to find the total distance. And we're going to find that by taking that length 7.1 and adding to it the length from Geordie to B, which we'll call JB, and Geordie to A, which we'll call JA. So if we can find these two lengths, we'll be able to put it all together to find the total distance that he travelled. Now, before we start, we want to try and use the clues that we've been given to create the most amount of sort of information possible that we can use to answer this question. We have no sort of full angles within this triangle. We have one side length, but that's not really enough so far to get this ball rolling. So what we might start looking at is clues. And before I start doing this, whenever I'm faced with a triangle that's, we've got bearings being given, and this isn't a right angle triangle, so it's a little bit more complicated, I start off by sort of turning it into a bit of a rectangle. So just continuing out these lines, like this, just because it helps me to see what's going on a little bit more clearly. Could be another story for you, but give it a try, and if it works for you, it works, and if not, keep experimenting. So what we can maybe see going on here now is we've got these two parallel lines, so these north-south lines. In fact, we've got three of them, one here, and one here. So if we've got 47 degrees occurring in here, that should also mean that this angle over here will also be 47 degrees, which means just like that, we have found the angle for corner B, or vertex B. So we've found that angle there. So B is going to be equal to 31 plus 47. So this new angle is going to be 78 degrees. Next, with the same sort of logic, we can see here we've got this 31 degrees in here. These are two parallel lines. Our 31 degrees in here also tells us we should have 31 degrees over here. These three angles should add up to make 180. So angle J is going to be equal to 180 minus 73 plus 31. Which if we whack that into a calculator, we should get a value of 76 degrees. So this angle in here should be worth 76 degrees. Finally, to get angle A, we can just subtract our two known angles from 180. Plugging this into a calculator, we should get an answer of 26 degrees. Now we've gone from having none of the angles in our triangle to all of them, which is going to make answering this question a lot easier. So, first finding the length JA. Well, we can use our sine rule in order to set up, we were given at the start this 7.1 meters along the side AB. We can relate that to this angle over here, 76, and use our sine rule to help us find these other sides, considering that we already have all the angles within this triangle. So to find JA, this side length here, we're going to use the 7.1 over sine 76 degrees that we were given, and our unknown JA is what we're trying to find, and this of course ends up being sine 78 degrees, so relating this side to this angle. Rearranging for JA, we get that JA is equal to sine 78 degrees times 7.1 over sine 76 degrees. I'm going to leave that like that for now, and we'll approximate once we plug it all into our final calculation. Moving on to side JB, we're going to use the same side we had before, that 7.1 over sine 76. And this is going to be equal to JB, which is this length here, over sine 26 degrees. Rearranging for JB, we get that JB is equal to sine 26 degrees times 7.1 over sine 76. And now we have everything that we need. So we plug it all into this original calculation. We get 7.1 plus JB, which we found to be sine 26 degrees times 7.1 over sine 76 degrees, plus JA, which we found to be sine 78 degrees times 7.1 over sine 76 degrees. Plugging all of this into a calculator, we should get an answer that rounds to one decimal place. That's 17.5 meters, which of course is option B. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I will see you in the next video.